Today, we're going to talk about average velocity and average speed. And there's a difference between the two, okay? So by definition, this is what average velocity is, okay? Average velocity is the displacement over the change in time, okay? Now, sometimes you'll see this. So V and then little average like that is equal to delta X over delta T. Now, sometimes you might also see it like this. For average, a lot of times we'll put a bar over it. So V, the velocity average with a bar over it like that, that's equal to the change in X, the displacement over the change in time. Now, this delta X is if we're going left and right. It would be delta Y if we're going up and down. But if you left it as delta X and you're going up and down, it wouldn't be a big deal, okay? I just want to make that clear. Now, this is an equation that we can manipulate. So what this means is that if we have two of these three things, we can find the third thing always, okay? So if we multiply both sides by delta T, okay, we would get delta X is equal to the average velocity times your delta T, your change in time, okay? Another thing you could do is if you multiply both sides by delta T and get this, then you could divide both sides by the average velocity. So we could take delta X and divide by the average velocity, V bar, and is equal to the change in time. So we can get the velocity if we know the displacement and the change in time. We can get the displacement if we know the average velocity and the change in time. And then if we know the change or the displacement and the average velocity, we could get the change in time, okay? And this is a lot of times the change in time is how long it takes something to happen, okay? All right. Now, average velocity is different. Velocity is different than speed because velocity takes into account direction, okay? So average velocity, let's say we're going 50 miles an hour, okay? And we go 50 miles to the, let's say, east. And let me get another color. And then let's say we turned really quickly, okay? And we went 50 miles, let's say west. So that'd be negative 50. Okay, so we went 50 to the right, basically, and we went 50 to the left, and that'd be miles. Our delta T, or delta X rather, our delta X would be 0 here because 50 and negative 50 make 0, okay? So our average velocity would actually be, if we went 50 miles to the right and 50 miles to the east, and let's say we did that in 2 hours, so delta T is equal to 2 hours, okay? And this would be in miles. Okay, so our average velocity in this case would be our delta X, which is 0 miles, over 2 hours, which would be 0 miles per hour. Now that does not mean that you didn't have any speed, okay? It's just the average of all of them came out to be 0, okay? So sometimes you're going more than 50, sometimes you were well, it's not 50. This does not mean you're going 0 miles per hour the whole time. That's my point, okay? It's because these two cancel out is what happens, okay? So let's look at this, but let's look at this from average speed, okay? All right? So I'm gonna slide this up a little bit, okay? So average speed is a little different. It's the distance traveled over the change in time, okay? So there's no symbols for distance traveled. There is for this, okay? So we could say equals and then write distance traveled. Over delta T. And there's really no symbol that I'm aware of for average speed, okay? There is for speed, but not average speed, okay? So if we know the average speed, okay, and we were to multiply that by our change in time, so we're multiplying average speed by change in time, delta t, that would equal the distance traveled. Okay, if I took the average speed, or if I took this distance traveled and divided by the average speed, I'd be left with the change in time. So change in time could be achieved by taking the distance traveled and dividing by the average speed. Now, okay, please don't think, oh, I have to have all these memorized. No, 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 no. I want you to know that the average speed is the distance traveled over the change in time. And I want you to know that average velocity is the displacement over the change in time, and then be able to manipulate that. I'll show you in the examples in just a minute. Okay. So right here, what would be our average speed if we went 50 miles right, and then we went 50 miles left? So that'd be negative 50 miles. And we did this in 2 hours. Okay, so my distance traveled and let me slide it up a little bit. My distance traveled, okay, would equal this 50 miles plus this 50 miles. Remember, sign doesn't matter. You still went 50 miles. And so that would be 100 miles, okay? So what would that mean for the average speed? Well, the average speed would be the 100 miles, because that's the distance I actually traveled, divided by the time it took me, which is 2 hours. That's the delta t. And that would give me 50 miles per hour. Or 50, I don't know why I wrote that, mph. That's how we normally write miles per hour. Okay, silly me. All right. Okay, let's go and let's do our first examples. So here's the first example. Tom runs rightward 320 meters, then turns and runs 410 meters leftward. Tom's total running time is 135 seconds. What is Tom's average velocity and what is Tom's average speed? Okay, so let's work on the average velocity first, okay? So we need displacement, which is delta x. Okay, so we know he went rightward 320 meters, so he went right, so plus 320 meters. And then he turns and runs 410 meters leftward, so that's going to be a little bit more, so I'm going to draw it a little bit longer. Okay, and then that'd be minus 410 meters, right? Okay, so we're going to take the positive 320 meters and we're going to minus 410 meters, okay? And that would give you negative 90 meters, okay? And you can put that into your calculator, okay, and get it. All right, what's our delta t? Well, our change in time, it took him how long to do this? Well, 135 seconds. So that's my change in time. So 135 seconds. All right. So my average velocity, V bar, would be equal to negative 90 meters divided by 135 meters. Okay. And you know what? I should have said this. Let's put a decimal here. Okay. I wish I'd done that. Okay, because I want to talk about significant figures. Okay, so 320 and 410 with decimals, then that would mean this needs to be not just negative 90, but negative 90 point. Okay. All right. So it's negative 90 point. Okay. So here's my point. All right. So this has two significant figures. This one has three significant figures. When we divide, okay, we remember we use the least one. Okay. So this is going to be, our answer is going to be in with two significant figures. So V bar would be, I'm going to grab my calculator and I'm going to put in negative 90 divided by 135. And I get negative 0.6. Okay, so we get negative 0.6666, and so on, right? If I want to go to two significant figures, okay, so there's my first one, there's my second one, here's the third one, right? I got to use this third one to figure out how to write that second one. So my average velocity would be negative 0.67, and then it'd be meters per second. Okay, let's talk about distance traveled. So distance traveled. Okay, so it'd be 320 meters because he traveled that. 320 with a decimal meters, plus he also traveled the 410 meters. And 410 with a decimal, okay? So the distance traveled would be 320 plus 410. That would be 730 with the decimal meters. Okay, and then again, my delta T is this 135 seconds. So my average speed, and I would just write average like this and then write speed, is equal to the 730 with a decimal divided by 135 seconds. Okay, so each of these has three significant figures. So our answer is going to have three significant figures. So we're going to take 730 and divide by 135, and we get 5.407. 407. Okay, so here's my first significant figure. Here's my second one. I need three because each of these has three. So I'm going to look at the third one, or I'm going to use the third one, and I'm going to look at the fourth one to determine. And the 7 tells me I need to round it up, right? So this becomes 5.41 meters per second. And that's the average speed. So there's a difference between, this is my point, there's a difference between average speed and average velocity, okay? So for this next example, during a race on level ground, Andra runs with an average velocity of 6.02 meters per second to the west. What is Andra's displacement after 137 seconds? Okay, so this is a velocity, okay, and we're going to the west. So remember, okay, this is, the top is north, the bottom is south, the left is west, and the right is east. And east would be positive and north would be positive, which means west would be in the negative direction and so would south. Okay, so the average velocity, V bar, we know is negative 6.02. Now, why am I saying negative? Because it's west, okay, to the west. So it's negative 6.02 meters per second. Okay, so I know that, and I know my delta T. My delta T is 137 seconds. So what we have is negative 6.02 meters per second. That's the average velocity, has to equal my displacement, which I'm going to call delta X, over the change in time, which is 137 seconds. Okay, now how do I get this delta X? Well, I'm dividing by 137, so all I need to do is multiply both sides of this equation by 137. So I'm going to put delta X on, it's on the right-hand side. I'm going to actually just write it on the left-hand side. Okay, so delta X is equal to this negative 6.02 meters per second, and I'm going to multiply that by 137 seconds, and my delta X. Now notice, I'm dividing by seconds, but I'm also multiplying by seconds, right? So those are going to cancel each other out like we did in dimensional analysis, okay? So this is negative 6.02 times 137, and we get negative 824.74 meters. Now that's way more significant figures than we should have, okay? So we have here, we have 3, right? And here we have 3. So our answer should only have 3, okay? So that means this is our first one, this is our second one, this is our third one. We're going to look at this fourth one, which is 7, to determine. And because it's 7, we're going to round that 4 up. So my displacement, my delta x, should be equivalent to negative 825 meters. Okay, and that's how you do these, all right? A high school runner's average speed for this example was 7.41 meters per second. What would the runner's time be in a 400-meter race? And that has a decimal in it. I had to add it, okay? 400-meter race, okay? All right, so what do we know? Okay, so we know the average speed, right? So we know the average speed is equal to 7.41 meters per second. We also know the distance that we're going to run, right? So distance traveled is equal to 400 meters, right? Okay, so I know that the average velocity, or average speed is equal to the distance traveled over my change in time. So I know this one and this one, so I'm going to need to solve for this one. So we have 7, this is going to be 7.41, and that's meters per second, is equal to the distance traveled, which is 400 meters over my delta t. Okay, so I'm going to multiply both sides by this delta t. So that gives me 7.41 meters per second times delta t is equal to 400 meters. And so now I'm going to, okay, I'm multiplying this delta t, and that's what I'm trying to figure out. I'm multiplying this by 7.41 meters per second. So what I'm going to do is I'm going to divide by it. So delta t is equal to 400 decimal with meters over 7.41 meters per second. Okay, I'm gonna do, you can think of these units as being like variables, okay? So I wanna show, well, I'm gonna show you, this is gonna come out to be seconds, okay? Sorry, I was thinking how I was gonna do this. This is gonna come out to be seconds, but why, right? Why? Why is that gonna come out to be seconds? I have meters divided by meters per second. Why is that gonna come out to be seconds? Okay, so it has to do with thinking about dividing, because this is a division problem, okay? So this is equivalent to 400 with a decimal meters, and then divided by, and this is, underneath the 7.41, there's actually a 1. So this is 7.41 meters over 1 second, okay? And so this is the only way I can explain it to you guys right now, because there's some stuff in Honors Math 3 that you guys haven't covered yet, okay? So what you can do is, well, how do we divide fractions? Well, you take the first number, right? So 400 meters, and you change this to multiplication, but you remember what you have to do is you have to flip this. So this actually becomes 1 second over 7.41 meters. Now this seconds, I'm going to bring these together, Okay. And so what you're left with for our delta t is 400 decimal times 1 would be 400 with the decimal. And then this would be meters times seconds over 7.41 meters. And this is why it becomes seconds, because these meters cancel each other out. So we're left with 400 with the decimal over 7.41, and the units on this would be seconds. Okay, so we're going to take our calculator and take 400 and divide by 7.41, and we get for a time 53.9811 0661. Now, how many decimal places can we actually have? Well, there's 3 significant figures here. There's 3 significant figures here. So our answer should only have 3 significant figures. And I said decimals just a minute ago, and I meant significant figures, okay? So when we divided these, right, this one has 3 significant figures. This one has 3 significant figures. Whichever has the least, well, they're the same. So our answer has to have the same number of significant figures. So 53.98, this 8 is going to cause the 9, and this is going to be kind of cascading, okay? And that 9 is going to cause the 3 to go up. So my delta t would be 54.0, and I need the 0.0 because that's the 3 significant figures. This has 3 significant figures. Remember, this is a trailing 0, and we count it because there's a decimal in our answer. So 54.0 seconds. Okay, and that would be what the runner's time would be in the 400-meter race, 54 seconds. Okay. Okay, so now on this problem, a cyclist rode with an average speed of 8.7 meters per second. The cyclist rode for 1.3 hours. How far did the cyclist ride? Okay, so there's a huge problem that we need to pay attention to on this, okay? Yes, we have the average speed. We have the time, right? We have the delta t. So we're trying to find the distance traveled, okay? How far did the cyclist ride? That'd be the distance traveled. Okay, there's a big, huge problem that we all have to recognize when we do these problems. This time unit is in seconds. And this time unit is in hours. Okay, to do any kind of mathematics on this, the units have to match. The units have to match. Okay, so what I have to do is convert the hours. I think this would be the easiest. Convert the hours to seconds. Now, you could also convert the 8.7 to meters per hour. Okay, but that's going to get you a really small number here. Okay, so what I would do instead is switch this and turn this into seconds. Okay, so we got to do a little dimensional analysis. All right, so we should know that and you could do this a couple ways. Okay, but now you may know that 1 hour is equivalent to 3,600 seconds. Okay, so we have 1.3 hours times, and I know 1 hour is equivalent to 3,600 seconds. Okay, you could also do 1 hour 60 minutes, and 60 minutes is 6, and 1 minute is 60 seconds, and go about that, and you'd get the same answer I'm going to get here. Okay, so 1.3 times 3,600 all right, is 4,680. Seconds, okay? Now, we're going to take the 8.7. So we know our average speed is 8.7 meters per second. And we know that's going to equal the distance traveled, which is we're just going to write distance traveled. I don't have a name for it. over the change in time, which is 4,680 seconds. So I'm going to multiply both of these by the 4,680 to cancel this out. So, and I'm going to put the distance traveled on the left-hand side. So distance traveled would be the 8.7 meters per second times 4,680 seconds. Okay. And then we're going to go to multiply these. Now, when we go to multiply these, this only has 2 significant figures, and this one has 1, 2, 3 significant figures. So we're going to round our answer to 2 significant figures. Okay. So 8.7 times 4,680. And that gives us 40,716 meters, because here we're multiplying by seconds, but we're also dividing by seconds, so the seconds cancel. Okay, now, like I said, we can only have I didn't mean to say decimal places, 2 significant figures, because this one has 2 and this one has 3. So you always have to go with the least, which is 2. Okay, so here's this 4 is my first one. This 0 right here is my second one. The 7 is going to tell me to round this up. So we would answer this with 41,000 meters. And that would be approximately how far he traveled. Okay? Okay, so an elevator travels up and down. A vertical position of the elevator in meters over time is shown below. Okay, so this is the change in position over time. Okay, what is the elevator's average velocity? So average velocity between 0 seconds and 28 seconds. So average velocity is the displacement over the change in time. So we know that our delta x, okay, so from 0 to 8, there's no change, right? So that'd be 0. And technically, I should have called this delta y because it's going up and down. It's an elevator, okay? And then from 8 to 16 seconds, well, it went from 12 to 0, so that's a decrease of 12, so minus 12 meters. And then from 16 to 20 seconds, it went from 0 meters to 15 meters. So it went down 15 meters. So another minus 15 meters. And then from 20 to 24, it went from negative 15 to negative 6. Now that's going up, right? So that's an increase. I'm going to put plus. And then how far did it go up? Well, each of these is 3. So 3, 6, 9. It went up 9 meters. And then from 24 to 28, there was no change in it, right? So plus 0. Okay, so we have negative 12 minus 15, that'd be negative 27, and negative 27 plus the 9. So negative 27 plus 9, that would give you negative 18. And so that would be our change in position. It would be negative 18 meters. All right. Now, so that means it went more down than it went up, okay? So now we also know our delta t. Our delta t is 0 to 28, so that'd be 28 seconds. By the way, I should have said this, delta t is always going to be positive, okay? So our average velocity, so v bar, is equal to our displacement, which is negative 18, divided by 28 seconds. Now, each of these has 2 significant figures. So when we divide this, our answer should have 2 significant figures, okay? So I'm going to take negative 18 and divide by 28, and I get negative 0.64285. $71429. Okay, so like I said, 2 decimal places, right? Or I keep saying that, 2 significant figures. V bar is negative 0.6. Okay, so this 4 is my second one. I'm going to look at the third one, which is 2, which says keep it a 4. So negative 0.64, and this would be meters per second. All right, so the next one that we need to do is this same type of problem, but it's going to be the average speed. So I'm going to zoom out a little bit because I still need to use that graph. Okay, so what is the elevator's average speed between 0 and 28 seconds? So I need to figure out the distance traveled. Which would be, okay, so what happens is all of these become positive. So we have the 0 meters, which you wouldn't have to write, and then plus 12 meters, and then plus 15 meters. Because the negative right here just means it went down, okay? Regardless if it went down, up or down, it still moved, right? So that's distance that we traveled, okay? And then plus the 9 meters, and then plus the 0 meters. It's basically this one with all of them just being positive, okay? If that helps you out. So 12 meters and 15 meters makes 27 meters, and 27 and 9 meters makes 36 meters. Okay, and again, I know my delta T is equal to 28 seconds. Okay, so I know my average speed is equal to my distance traveled, which is 36 meters, and divide by 28 seconds. So you see they come out different, right? Okay, so 36 divided by 28, and we need to go 2 decimal places. Okay, so the average speed, or I keep saying decimal places, I mean significant figures. Okay, so 1.28, that 8 is going to make the 2 become a 3. So this is 1.3 meters per second. I should have put this. Okay, so this is 1.28571428.6 meters per second. So this 8 right here is the 8 I'm just talking about, okay? The 8 is going to cause the 2 to go up to a 3, and that would give me 2 significant figures, just like these two, okay? So that's how you find, okay, average velocity versus average speed. So average velocity, once again, average velocity is the displacement over the change in time, and average speed is the distance traveled over the change in time. Almost identical, right? One's displacement, one's distance traveled. That's why last week I taught you guys displacement and distance traveled, okay? All right, you guys, so after you complete this, go back to Zoom and we'll have a debrief at the time I told you, okay?